have from our very own country, from Suriname, we have Miss Minu. And all the way from Brazil, we have Mr. Let me just say his name correctly, Mauro. Mauro, bom dia, meu amigo, bom dia. No, boa tarde, boa tarde. Can I please have an applause for Mr. Mauro and mevrouw Minu? En zij gaan praten over biodiversity.
The pleasure.
I think it's better together.
Okay. Yep.
Is that this way? I think so.
Maybe not. Let's see. Hello. Well, I'm so excited to be here, and let's see if we can show to you guys how biodiversity and Bitcoin connects. So I'm Mauro. I'm a scientist, which means I look at the world through the lenses of the scientific method, which is so far the best tool that humans have created to solve problems. And when I first got in contact with Bitcoin, I said, wow, this is amazing. It's going to solve a lot of problems. But it's not going to solve all problems. So we still need clean air. We still need water. So there's a thing about like apps, bytes are not going to solve all the problems of the world. So we still need innovation in atoms. And for those like me who were yesterday in the middle of the forest, it's very easy to see how all the benefits that Bitcoin can bring to us are not going to be valuable if we cannot still experience the world that we live in, right? Yeah. So when I first heard Maya talking in a podcast, and that was that one sentence that she said that impressed me more than all the plan to paint Suriname orange, which is the fact that 94% of the country is covered with Amazon. So in that moment, I thought, wow, if she can paint it orange without cutting the green, this is going to be not just one more Bitcoin experiment. It's going to be like a world, it's a revolution, right? So since then, and that was maybe June,
Yeah.
I got in touch with her, and she introduced me to Minu. She's going to talk about the organization that she runs, ACT, Amazon Conservation Team, and we tried to develop a pilot we developed a pilot to try to show how we can solve a lot of the problems related to biodiversity conservation, okay? So I wanted to show this because it's very impressive, right? For those who didn't see from the plane, it's a green carpet.
Which I helped to protect.
Yes.
Okay? All right.
So it's a green carpet. And if we don't take care of it, it's going to happen this, which unfortunately is Brazil. So a lot of deforestation, mainly for cattle raise, and then after the cattle comes the soybeans. But most of all, it's driven by poverty. Because, like, there's even crime related to it, because the main driver of deforestation is land grabbing, illegal land grabbing. But even if with the program of the government, a poor family gets a piece of land, the first thing they do is to put fire on it. And they do it because, in a crazy, twisted way, the land with the forest worths less than the land without the forest. So they cannot sell that piece of land that they got if they have forest on it. But no one who wants to buy the forest, to buy that land, wants to buy it with forest. So, they kind of use the poor people to do the legal firing. So after that, it's already burned.
True.
So, yeah, we might as well put some cattle on it. And then, after they exhaust, the cattle moves on and the soya comes. And that's how it's been for, I don't know, maybe 3, 4, 5 centuries. So, yes, every country that wants to develop and take their population out of poverty faces a challenge with biodiversity conservation. One, because if you look back a century or a little bit more, you can see a direct correlation between reduction in poverty and supply of cheap, reliable energy, right? So if we want to get people out of poverty, you can be sure you need more energy. But we know now that we don't need more land. So land is not a limiting factor. So if you look, the world today has about 3 billion hectares of forests, 1.5 billion hectares of agriculture lands, and 1.5 billion hectares of pastures, and 1.5 billion hectares of degraded pastures. So if we just use all these degraded area that we have, we don't need to put down 1 hectare of forest to develop any nation. So this is very good because we can do it. However, if we still use low-tech solutions, so when the energy comes, people will need to use this energy in a creative way, to generate wealth. And if we still use low-tech, all these low-tech solutions, they have a huge environmental impact. So a way to further develop people without the environmental footprint is to try to monetize biodiversity. Okay? And this is what and this is somehow the connection with Bitcoin, because I want to monetize it in Bitcoin, right? And so there are 2 ways to monetize biodiversity, in short. One is biodiversity credits, the other is bioprospection. We'll focus today on the first one. The second one, it's a bit more complicated, but you just need scientists. Luckily, there are a lot of them in the world. But monetized biodiversity has a problem. And for those familiar with carbon markets, the problem is the same as the carbon, which is to measure, to report, and to verify, right? MRV is the acronym for these 3 words that are related to all the problems in the carbon markets that extends to biodiversity. So, in the end, is a trust problem, right? So we have a technological problem, which is the measure, because biodiversity is vast, very big. And it is very, very difficult to measure. So the first problem to be able to monetize it is it's to measure. And so far, this has been the limiting problem. If you can measure, and I will show you in a second how, then you have the problem of reporting, because if it is so vast, it's what we call big data, and humans, the human brain, cannot deal with it. It's just so much information, right? So reporting is a problem. And then the verify is a disaster. Simply, like it's either you do the job or you verify the job, because then when you verify, so me and my team have spent a lot of time trying to solve these three things for biodiversity, so we can enable a biodiversity credit market that will enable monetization of biodiversity and development without the footprint. So the problem of measuring is solved with a technology called environmental DNA. So, the way we have been identifying species for the last, I don't know how many centuries, is by morphology. So how a species look like, their format. So how many arms, how many legs, how many atoms, how many eyes, anything. And this is difficult because, you have to look. Sometimes organisms are very, very small, and it is an individual thing, and it's time-consuming, it's laborious, and you simply cannot do it, or not fast enough, good enough. So what some very smart people we started to do some 20 years ago was to use DNA to identify species. And DNA, the genetic code, it's good because every species, it doesn't matter if it's a bacteria or if it's humans, we all have DNA, right? And only us, living organisms, have DNA. So rocks don't have DNA, water don't have DNA. So if there is DNA, it came from an organism. And if it is an organism, it has DNA. So for the purpose of this presentation, you have to trust me on this, but you can later verify. But believe me that we can use DNA to, in an automated way, measure all the biodiversity. And yes, then the report part of this measurement used to be a list of species. And imagine if I can go and get all the DNA of all the species in the environment, and you have a very, very long list that I said, like, humans cannot deal with it. So what we did was to create a report that is a file that a computer can read. So what we did was, for those, I know there's a lot of tech people here, we just use a JSON file, and we are putting everything there. So we kind of changed the way that usually is, a human wants to look at the data, and then you have to simplify so much the report that it was difficult to do anything with it. So what we did was to reverse this. Our report is machine-friendly first, and then human-friendly second, based on all these files, right? And okay, we are not the only ones doing DNA measurements to look at biodiversity, to put in a text, in a file format. It's not that complicated. The tricky part was, how do we solve the trust problem, the verification problem, right? And because whenever we speak about this, every client, which can be an oil company that wants to offset damage to the environment, or is a forest, or a project like Minu that has the biodiversity and wants to demonstrate to the world that their effort in conservation is legitimate and it's authentic. But if it's difficult to measure, it's difficult to report, like verify how, and nobody wants to, so there is a reputation, everything related with carbon and biodiversity, there's a lot of reputation risk involved, right? Because it's not the carbon or the biodiversity, it's actually, if your activity creates damage, then you have a big image problem associated with it. So all the things in this sector, they are very
sensitive.
Sensitive. Thank you. So it is very, very important to guarantee integrity of these measurements if we want to monetize so people can know what they are paying for, right? And usually this task of verifying this is outsourced to a trusted authority, which is a certifier. And we know that certifiers make mistakes also, or sometimes they are not as trustworthy as we thought or wanted them to be. And what I wanted to do is like, I don't want to need a certifier. I just want to demonstrate, to allow people to do like I know you can do in a blockchain, in Bitcoin, to allow everyone to verify the legitimacy of a transaction or the integrity of a given data at any time, right? So we created a platform that that is here in beta format. We can walk through this if you guys want to, but I wanted to keep simple on the, on a representation of this. Which is, imagine, that first square as the forest. So you have a lot of species. And trust me, we can go there, get a liter of water or 100 grams of soil and extract, and that small sample, because DNA is so small, and it's so widespread, it's so abundant, that even these small samples of the environment will have DNA from all the species there. It's not that simple, because sometimes this is in the middle of the, of that green carpet, and Minu had to go there with an helicopter to get the samples that we will show. But, in this small, everything goes into a small tube, all the DNA is there, and we put that into a machine, which is the DNA sequencer, that gives this result. So it turns chemical information, which is the basis of DNA, adenosine, cytosine, thymine, and guanine. So this is the chemical information, and the order, like T, A, C, T, A, C, G, this is the biological information, because this is the order that's going to create all the proteins that are going to build all the organisms. And so this machine is very important because it's taking physical information and atoms and turning it into bytes. And the moment it does that, it creates the kind of file that we can apply cryptography on it. So now I have kind of a digital twin of something in the real world, right? Because all the DNA that we took from there, it's now converted into a file, and it's so much DNA, so many species, that it is a fingerprint of that environment that you cannot temper. So, or at least if you have enough samples, people can compare, and statistically will tell us, well, this is from this environment, not that, because we have other samples to compare. And so what we did is, okay, now we converted the atoms into bytes. So now I can hash it, apply cryptography, and I can protect the integrity of this data. If someone tried to change this data, the hash will change, and we will know that there was an attempt to tamper with the data. But still, people can pretend the data never existed. So let's assume yesterday we were in this beautiful beach by the river, and I should have taken some filters with me. We were there, and there is all that biodiversity. But maybe in 10 years there will be an oil spill. And if there is an oil spill, people can say, well, the damage was not that big. And, well, there's no, but if there's no baseline to compare, someone can say whatever they want, right? So, if we do have a baseline, people could still say, well, or they could try to bribe me to make the file disappear, right? But if I take then this file and record on the blockchain, then this is proof of existence. And nobody can say that this sample never existed. And this creates then a mechanism in which you can take a picture of the biodiversity in space and time and make it live forever and be able to compare. And this has value because you can attach this to a reputation, right? So the ones doing the conservation effort can say, look, this is verifiable. Here's how my effort to conserve translates into species in the environment. And no attempt to change this will, and it's not going to be possible to change this, this real value that was created with this measurement, right? So at the same time, someone that needs to offset their environmental damage, because that's the nature of their operation, will be able to support a conservation effort and be sure that that's not greenwashing, or there's no, they are not being manipulated from the other side. So like, if you support an effort, you want to make sure that that the value that you are acquiring is real, exists, and also cannot be manipulated. And what we did was to do that in a way that it's automatable and that it's verifiable by anyone. So 100% fully transparent. And just to finish, the advantage of it is that, we are used to think about small properties. Even big farms are what? 100,000 hectares. The reserve that they are in the south of Suriname, it's 100,000 hectares. Still, Suriname has 70 million hectares. So whatever you do to protect and to monetize biodiversity has to be able to grow at scale, right? if you take the 3 billion hectares of forests around the world, we need to protect this, so we need solutions at scale. So that's what we tried to develop. And now, yes, I will pass to Minu that is going to
Okay, thank you,
talk
Mauro.
about the pilot itself.
Good afternoon, everybody. I will try to bring you closer to Suriname. So after Mauro got excited all about the opportunity of starting a pilot project in Suriname, we tried to understand what he was doing, because it's not that simple to understand. And in his attempt to getting a number of pilots in the Amazon, we thought it's coming at a right moment where Suriname is trying to get international attention for all the 90% forest cover, 93, 94% forest cover. In that sense, we thought it would be great to also delve into the biodiversity side of things. Now, coming just from the COP, we know there's a lot of contradictory around controversy around biodiversity credits and carbon credits, because in general, people believe that the polluter pays and is not actually gets all the freedom to continue business as usual. So that's the main controversy in the world. And second one is that benefits or credits from these mechanisms are not directly going to the people who are really engaged in protecting it and having it led to the situation where we are now, having the 90% of forest covers. Having said that, we have still started this partnership, and ACT, Amazon Conservation Team, we work in the 3 Guyanas. There's a map out there, working with the indigenous and tribal communities. Tribals are the descendants of Afro, living and started their settlements way back in time. So we're part only 2% of the Amazon, of the huge, vast Amazon you live in. So we all only cover around 2-3% of the Amazon. However, when you compare our 90% forest cover, to the huge countries, in the landscape of donors, we lose interest. Why? We are small in size, we are small in population, and the challenges we present as a state or an NGO of the local communities are often, so small scale when it's compared with the huge problems and the huge acreage set forward by the giants on this continent. Sorry, Mauro. So we need to be creative all the time in getting attention. So we're working around 3 strategies to achieve or maintain the forest cover. The conservation goal of ours is to keep a healthy forest and to protect and to work towards human well-being, so strengthening the community, all within the context of biocultural conservation. Now, in the pilot we started with Mauro, we looked at the Rangers program that was created back in 2007, yes, with indigenous and tribal community. At this moment, we have around 40+ rangers who are trained, equipped, and do the patrolling, the education, the awareness raising, and the applied research in the territories. Now for that, you need to sustain this system that we have invested in, the locals that are very proud to do the work, and financial mechanisms are an important one. Somehow we have been able to continue this since the start, but being an NGO, we also need to delve into new opportunities. This is just a slide showing you what different types of work the rangers are doing. And finally, we compared business as usual from our side with the more innovative way of looking at technology and doing applied research. So basically, think about a very remote area where you need to be physically present to take samples to understand what a biodiversity is, to take the sample, drop them at the lab, wait a few months, sometimes it's a year or so on, get the data back and communicate, get attention, and try to improve on the conservation side if threats were identified, or try to advocate for revised legislation. Now, this is what we did actually with Mauro together. We were able to sample only four sample locations in a nature reserve. That was the first time that we did a field trip with a helicopter because we wanted to check how efficient it is. And to your left, you will see that that was the result that we received in 2 months' time, I guess.
Yes.
2 months after sampling an exhausted list of the species, eDNA, identified in the lab with 4 sample sites. 4 sample sites with a number of replication to ensure that the gene were not compromised, I guess, or the samples were not compromised. And what is this saying? This is saying that this is an idea of the locations we went to. This is close. The map is showing you that it's close to Brazil. It's very remote. And what is saying that in not only using new technology, you can be cost effective, but in order to protect, be timely with conservation measures, you need to ensure that the funds are there. So biodiversity credit is one way. In a country like ours, you know that legislation and regulation need still to be framed around these topics. However, there are some pilots that we could start where you create funding for these rangers to do the work because they have been doing it, they have been protecting it, now they have been monitoring it, and so on and so forth. And there is space to elevate it to a higher level. If I have been listening correctly to you guys who are the experts in the Bitcoin landscape, transparency, creation of foundations, and having locals become part of inclusiveness of all that is happening nationally. I think these opportunities in Suriname should be incorporated in at least pilots. Somebody said it before, I think you guys were at start doing it. Start and don't, just wait for another to. Just do. Just do. So that is what we did. We started a pilot, but the next step is to go from here to another one, where you have transparency and include from the local level the communities who are engaged in conservation. So that was my contribution for this afternoon. Thank you so much.
So I think this was a little bit the idea that if we have a problem, so that there is a trust problem to be able to monetize biodiversity. And if there is a trust problem, decentralization offers a trustless solution, and that's what we try to create. So we can foresee a scenario in which, while this country starts to monetize the oil, it will require, but the oil industry traditionally requires offsetting. So it's a way to double, how do you say, to
Revenues?
keep not only the royalties from oil in the country, but also to even find a way to keep all the revenue of offsetting inside the country as well, in a way that helps maintaining the green carpet. Okay, we want now to know if you have any questions, And yes, it would be great to discuss if you have any ideas of further business models that we could use to make sure that we will monetize this with Bitcoin. I see one hand over there.
Hi. I'm very happy that someone is trying to protect my country. So I'm very happy with your efforts. I was wondering what your problems are, because apparently it sounds like you already have the solution. You have a machine, you put some soil in it, you get some JSON file, put it in the cloud, get a hash, and now you have verifiable how much what the ecosystem looks like. Now, after a year, when the oil and the gas industry comes, you do another sample, you go like, hey, listen, the industry changed the biologically environment, so you need to pay up more. So somehow it sounds like you solved it. On the other hand, I'm thinking, like you said, trust is a problem. So how do I know that even though you put a machine there, that you did not manipulate the machine to say that it was greener than it actually is?
Yes.
How do I know that after the oil industry comes, that you did not modify the machine, that it's not worse than it actually is? And as you said, we can put 1 million of these machines, but well, if I'm the oil industry, I put 4 more million of those machines, disputing what you just said. So even though we created a file, I somehow still need to verify that the machine was measured, that it's actually producing trustworthy results.
Yes.
And more of those things. That's one thing. And the second thing, I'm really happy with what you're doing. So I would really like to, after the conference, talk on how we can improve all of this, because I would like to help.
Okay. So if I understood correctly, you would like to know how we can verify not just the integrity of the results, but the quality, the representativeness, right? Or the quality of the results. So one way that we are, so I'll try to, so what were the points of failure of the system, right? So one point of failure is the sequencing machine, because that's the moment where the atoms are being turned into bytes, right? So yes, this is a point of failure, and if someone hacks the sequencer, because the file that comes out of the sequencer comes already with a hash, right? So, but still you can hack the machine and make some species disappear, or introduce, like make some genetic code disappear, or introduce some genetic code there. So I needed to guarantee the integrity of the samples even before, right? And that's an even bigger point of failure, because so Minu came to Brazil to bring us the small tubes with the sample, and I had to trust her, that actually had to trust someone on their team, that they actually went to the forest and they didn't get, I don't know, tap water from home. And that was the biggest problem for me. How do I guarantee that that sample came from where someone is declaring that it came from? So the idea that we had is, because there's so much information in the sample, so much, the sample itself is a fingerprint of that environment, and one that if you have enough samples, you cannot fake. Because, if you have something that is very complex, if you try to introduce or remove information, you reduce the complexity, one way or another. And statistics, using statistics to compare samples, you'll be able to identify these attempts to manipulate this fingerprint. But it only works if you have enough samples. And the good thing about this is, it's not that expensive to do it. So the cost of analyzing one sample, not at scale, it's around $100. And a lot of citizen scientists are doing it for fun, the same way that any of you can hire 23andMe and paying $100 can get your genome sequenced. People are getting samples of their backyards. I want to know what's in here. And I like this lake. I'm going to analyze what is here. So a lot of independent samples are coming up on the web, right? So and if you, or if an agent that it's not well intended wants to fake a sample, any one of us can go to the same environment and do an independent analysis. And the same way, so what you're seeing here is not Suriname, is Brazil. These are 3 hydroelectric reservoirs. Okay? So this is São Paulo state. You have the Tietê River, the river that crosses São Paulo. And so you have a hydroelectric reservoir that is arriving into the Paraná River, which is the La Plata River, but just in Brazil. You have a second reservoir there, and a third reservoir in the Paranapanema River here on the basin. So we got all the DNA data and applied the same statistics that Minu showed that could separate the savanna from the rest of the forest. And what you can see is that they aggregate together based on the content of the sample. So all the yellows are one reservoir, all the greens are another reservoir, and all the blue are a third reservoir. And there's no one saying which sample came from where. We are just comparing using principal component analysis or principal coordinate analysis, which are samples that measure similarity, how similar these samples are to each other, or dissimilarity, how different they are from each other, and they aggregate samples that are similar. So this way, we have a proof of origin that is independent from any human declaration, right? So now you can test even this by yourself, because we are giving the raw data on boring. This is the JSON file, okay? And if you could see it there, it's on IPFS. So theoretically, in a distributed way, we were discussing yesterday, how can we actually guarantee that these files will be there forever? But you can access the raw data coming out of the sequencer. And so you have URLs there, and you have also the hash. So you can check if the file that is available, if the file that you can download is the file that we uploaded and came out of the sequencer. But you don't have to trust if it came from Brazil or Suriname, because you can use the statistics to test and to check that, that this proof of origin based on the fingerprint, that is the richness and the abundance of the of the DNA content. So it's I would love to hear if people think this is a good idea or not, but at least it's like miles away from everything that we have until today.
There's another question.
Yes, hello. Lars Magnus here from Norway. So I have a question. If I'm a builder, right, or an entrepreneur, say I want to build a road, how do you incentivize me to report whatever I'm finding? I might be finding a tree or maybe a lizard that's endangered. So how do you incentivize me to report this? Maybe I don't want people to know what I've found.
Yes. Well, in a way, good luck trying to keep it a secret. I don't think you can. Because like I said, it's cheap enough, and it is, let me share a different. I love this image, and the first time I saw it, I got so impressed. So this is the cost of sequencing a human genome over time, right? From 2001 to 2022. On the on the vertical axis, you can see that in 2001, to sequence a human genome costed $100 million. And now, costs less than 1,000. So this means, and this is, that one line is Moore's law for the silicon chip. It's it's the gold standard to evaluate how good the technology is. And the Moore's law is every year a chip is going to double in capacity and reduce to half of the cost, right? So DNA sequencing has evolved 10 times faster than Moore's law. The consequence of this is that we are going to sequence everything. All of us, all the bacteria inside us, all the biodiversity, everything. So soon, this is going to cost $1. So I don't think you can hide, because people will find out. It's not something, the barrier of entry, of access, it's getting lower and lower. So you might as well be the first one to say, look, yes, there's damage, how can I offset this? Okay? Because in the end, I believe that people need roads, people want electricity, people, we were talking during lunch, people want convenience, right? And convenience comes at a cost. And this is just giving transparency to the cost. And specifically in Brazil, what we are doing, we are partnering with an asphalt company because they want to sell an asphalt that already compensates the impact of the road. Okay? So every time the concessionary needs to recap the asphalt, they are offsetting the damage on the biodiversity. So this is one idea, but I don't think you can hide anymore. Like, not even if you are, so we have expeditions now in the equatorial margin looking into the DNA of species like 2,000 to 3,000 meters below the water. That's, you know, you go with the sailboat, you drop a grabber, it grabs like a kilo of mud, we can say everything that is in there. So the barrier of entry is lowering, and yes. That's why even comparing to our competitors that say, no, we give you a list of species, but the raw data is ours. I say, no, we're actually going to open everything. That's the competitive differential.
Thank you.
No.
Hi, my name is Rooney Calmera. Thank you for that. I got a feeling that this is a great potential for Suriname because Suriname is exporter of oil in the future, gold, and with this Bitcoin, and this seems like high tech because the Amazon, the forest is like a potential, like a resource that is valuable. And I got a feeling that that Suriname is, with this, is basically going into high tech, into artificial intelligence. If you combine it with Bitcoin, which is decentralized finance, that this could be another sector that gives Suriname wealth. And it is not only about, gold or oil, but this is like high tech. Suriname can be an example for the future. Can you comment on that? Is that what the potential we see here?
Oh, I will let
Yeah.
you help me with this.
Yes, we believe so. That, and especially looking at the ambitions of the government that they would like to start with the carbon. I mean, even with this, added to the ambitions of the government, this could be huge for Suriname. But there are some enabling conditions that we need to have in place. If we want to benefit from all the opportunities that we're now, presenting, and there are more than this, legislation, inclusiveness, having energy, water, and telecom in those rural areas to make them part of, what's happening in the society, could be perhaps funded from these innovative ways of gaining revenues. So yes, I do agree. We will need to, work harder and get an interest from the government and other actors. Yeah.
I think one of the challenges, like she said, with the regulation is that technology moves in a much faster pace, right? And what is happening, there is a rush all over the world to get biological data, to train AI, to do bioprospection, to create products, medicine, cosmetics, biofuels, better food, everything out of the biodiversity. And one, forest is infrastructure. Like, it took thousands of years to build this forest. If you let fire consume it, it's like destroying a city. A city that, you cannot rebuild a forest. Otherwise, there would be one tropical forest in Dubai, right? But it's hard. So it's very important to protect this infrastructure that holds vital information for, creative economy, right? And we have to develop the generation of scientists that will be able to extract this potential and turn it into products and services that are sustainable because they are based on biodiversity. You cannot do that with low tech, only with high tech. And it's one of the points of conflict that we witnessed in the biodiversity conference of the parts last week, that countries are still trying to protect the low-tech, biodiversity-rich countries are trying to use legislation and guilt to protect this asset and say, no, give my share. And the high-tech, low biodiversity countries are saying, look, it's not cheap to develop these things. There's a lot of risk. So you still have a conflict. But the thing is that for me, the biodiversity rich countries didn't get yet, is that it's actually much less expensive and easier to build a scientific community to use high tech to extract value from the forest than to rebuild the forest. Okay? So I think this is the opportunity that we cannot miss. And what excites me in Suriname is that here it's a manageable problem. In Brazil, it's very hard to manage this problem. Too many people, a lot of money coming out of this non-sustainable economy, right? Logging, $2 billion a year. Meat, $5 billion a year. Mining, $10 billion a year. Okay, it's very hard to, here, the problem is manageable. And then we can set the example. That's my impression and what excites me.
Yeah. Sure. Good. Thank you so much. Sure.
Yeah, yes. Thank you very much, Mauro and Minu.